Hi, so this is the last question that I set you for the travelling salesperson today. So this is question 5. Part A of it asks you to fill in the table of least distances down here. So I've copied it down here. There's a few gaps. So remember, it might not be the direct route between certain places. So for A to B, the direct is 35, but there's a slightly shorter way if you go ACB, so of 32. So I think that's the shortest one there. So pause the video if you haven't done it already and just have a quick go at filling in those. Okay, so the answers, AE is, what's the quickest way to get there? So, there's quite a few to check. So A to E, I could go up there and down there. Go there. Could go there. Go there. Go down there. So that way is quicker than that way. So I think that up there and there. So ACDE is 47. I think that's the shortest one for that one. The next one that we've got is CE to fill in. So CE, there's that way or that way, because those were clearly longer. That way, 21 plus 11 is shorter. So 32. And then the last one we've got to fill in is DG. So DG, I think it's going to get there, isn't it? Yeah, so DG 53, I think, is the shortest. Okay, so there's the table of least distances filled in. I'm just going to make another copy of that one so that I can do the next two parts of the question. Right, so I've got my extra copy. So part B of the question says to use the nearest neighbour algorithm starting from A to work out a route. So starting at A, obviously don't want to go back to A. So the shortest one down there is 15. Now looking down here, so this isn't a greedy algorithm, so I just look down the most recent one and go for the nearest neighbour from that one. So that's 17B. Now look down this column, and 38. Now look down this one. Takes me to E. Now look down column E. And then that takes me to G. So I've got all of my vertices have been visited now, and I just need to go back from G, where I am, to A. G to A is 23, so I mustn't forget to add that on. So my route is A, C, B, D, E, F, G, A, And then if I add up all the numbers in the circles, get 165. Okay. So that's my upper, well, that's an upper bound. Just put that there to remind myself. And then part C of the question says to delete A and to use the table to find a lower bound. So if I delete A, it's going to just take all of those out and all of those out. So I'm deleting all of the edges that come from A. And then you can either use prims or crystals, it doesn't matter, to find a minimum spanning tree that joins the rest of these up. So I'll use prims. So it doesn't matter where I start from because minimum spanning trees always end up being the same. So if I start from B, I don't want to go anywhere in B because I'm already there. The lowest one is 17. I'm already at C, so cross the rest of that out. Now, because this is a greedy algorithm to find a minimum spanning tree, so I can let down both of these, and the lowest number is 21. Takes me to D. And now I can let down all three of these, and the lowest number is that one. And then let down all of these, and the lowest number is 31. And then my cat in the background. And then let down all of these, and the lowest number is 30. And then, so we've got our minimum spanning tree, so we could draw it out if we wanted. We don't really need to, unless I can't remember what the question asked us to do. So adding all of those together, and then you need to add in the two shortest edges that are linked to A because you deleted A. So we've got 15 and 23 are the two we're going to add in. So the minimum spanning tree weight is 17 plus 21. 110. And then we'd want to add in the 15 and the 23. Okay, so I just checked the question. We don't need to draw the minimum spanning tree, but if you did, it would be fairly easy. It's never going to do any harm if you do want to. So, because actually these all kind of go in a straight line. So B, C, 17, C to D is 21, D to E is 11, E to F is 31, F to G is 30, and then we've joined in AC and AG. As our extras. So that's what our nearest neighbour algorithm route would look like. So that's not a Hamiltonian cycle. You can see that they'd have to go out and then out to B and back in. So that's the problem with that one. The question doesn't ask you to write an inequality, but if it did, then your solution would look like this. So it would be 148. So that's not an optimal, that's not a possible solution, a viable solution. So we don't have the equal to. I think you can just write weight there if you want. And the only upper bound we've got is 165. There might be a better one, but they didn't ask you to find any more. But if it was our lowest possible upper bound, then we'd have it there. So that's what our travelling salesperson answer would look like.